Hey, good evening, everybody. Welcome, welcome. You probably heard this webinar presented with a number of different titles. Really what it gets down to this evening is the fundamentals of drought. That's what we're going to be covering with a couple of really solid presentations, bookended by your introductions and by your questions. So I'll get started just by introducing myself. My name is Katie Getz, and I'm a policy analyst at the New Mexico Department of Agriculture. But tonight, the hat I'm wearing is that of the Southwest Drought Learning Network, in particular, the team related to drought and agriculture. So I also want to tip my hat to Sky, who's the co-lead on that team, and multiple members scattered across different agencies, across different states, across different organizations, including Kavira Coalition, are part of that team, are part of the Drought Learning Network. So I'll talk about that in a subsequent slide. We're glad you're here as part of the new agrarian program apprentice cohort for year one for most of you, it seems, and maybe some year two folks on the call this evening. So in just a minute, we'll turn it over to Dave Dubois, the New Mexico State Climatologist, as he talks to you about basically the fundamentals of drought, aridity, and weather. He'll then turn it over to Peter Goble, who has a multitude of hats as well. He's with the Colorado Climate Center, and there he is a service climatologist and drought specialist and Colorado Cocoa Ros coordinator. Correct me if I'm wrong, Peter. Actually, just remind me, Cocoa Ros. Community Collaborative Rain, Hail, and Snow Network, is that right?
You got it before I could even unmute.
Okay, good deal. Well, I'll have a little more confidence the next time I'm up to bat. So we'll turn it over to Peter to wrap us up with a presentation on weather and climate resources for farmers and ranchers in the Southwest, and certainly elsewhere, because we recognize that you all are scattered across Vancouver farms and ranches across the West. As I said, we'll wrap it up with a Q&A session and discussion and turn you loose by the promised time of 7:30. So again, welcome. Let me say a piece about the Southwest Drought Learning Network. It is still taking shape because it formed only as recently as February of last year. I know that probably feels like a long time ago, but everyone gathered in Las Cruces, and by everyone, I mean service providers, federal and state officials, scientists, stakeholders, coming from neighboring states, coming from national outfits like NOAA, the National Oceanic and Atmospheric Administration, if I got that one right, the National Weather Service, and national players like that. So really the mission here, it is to link those climate service providers with resource managers, natural resource managers and others, to do a couple of things. And it's really to increase resilience against drought and resilience at both the landscape and the community level. So how do we make our natural resource base more resilient against drought? How do we make people, ourselves, more resilient against drought? That's really the purpose of the network, is to bring those resources together to that end and combine our information, act as a clearinghouse, and then deliver that information to whichever public needs it. So we recognize that there's a strong interest among the next generation of farmers and ranchers, you all, in better understanding drought and how to make yourselves more resilient against it. So some of the resources you will find when you visit that website there at the bottom, webinars like what we're doing here tonight. There are parts of the team that are putting together podcasts. You'll find other drought tools there, some case studies if you want to go a little deeper, and also some published pieces of literature for those who really want to go deep. So I will grab that link in just a moment and offer it in the chat so that you can check it out when you have a moment.
One other piece of info that we wanted everyone to share, and we just don't have time to do all of it verbally, is just to hear from you. Like, are you seeing any impacts of drought at your mentor operation? And what are you seeing, or what are you hearing from them related to drought? So if you're on a computer and you're able to, we'd love for you to just drop that into the chat so folks presenting tonight can get a sense of what that is. Right. So Katie, I will turn it back over to you.
Thank you. And I think I've got one more question, so let me just go ahead and pull that up too. So I suppose if a person wanted to, they could just chime in and tick both boxes there. So the second question for anyone just listening is, where do you currently get drought information? So in other words, what are you seeing out the window, and what are you putting your ear to better understand the drought picture?
And maybe I'll just read a few of these out loud as they're coming in. Exacerbated wildfire stress and severe drought and Roundup, only 4 inches since October. Forage has dried out a month early. Seeing federal rules change with our CRP land and having to react to that. Someone who prepared a drought plan, but they were lucky enough to get a decent amount of rain. In one of the driest years that my mentors have seen on the ranch over the last 65 years. Our mentor is very concerned about drought this year as water rights are being shut off on different pasture daily. I've got one lucky person who's gotten a decent amount of rain the past couple of weeks. Worried about our row crops and cover crops growing properly or at all. Very short on irrigation water. Wells are going dry, pond has shrunk considerably. People are getting really concerned about next season. Our hay crop isn't coming in well. Also worried about forage for our cows and all pastures. And then one comment about where they get data from the Mesonet station from Montana Climate Office and CocoRa's. So cover crop started fine and now is stunted, and grasshoppers are going to be bad. Yeah, so I think if it wasn't already apparent, hearing from everyone, feels like this is an important topic for us to all be talking about.
Yeah, and a perfect segue to our first presentation, which is going to be delivered by Dave Dubois. As I said earlier, he's the state climatologist here in New Mexico, and he'll be speaking to you tonight just on the fundamentals. That's what brings us together this evening, to learn about drought, aridity, weather. So Dave, I'll give you a moment to get your screen pulled up and ready for a share, and I will stop sharing mine here and return myself to mute.
All right, let me hit the buttons here. So my name is Dave Dubois. I am physically sitting in southern New Mexico, and it's been nice and toasty here. Just a couple of weeks ago, I was visiting my family back in New Jersey, and you probably didn't know that there was a lot of farms back in New Jersey, but my extended family are still there farming out there, about 4,000 acres of all kind of stuff, and they're just planting their sweet corn when I was leaving, so it was just nice. I'm going to miss the crops. Sweet corn is one of my favorite. Other than I like it when they plant spinach. That's getting like 300 acres of spinach. You can just go and get some spinach, and that it just and it's interesting. We're going to talk about climate, drought, aridity, and my dad takes he collects rainfall at the farm, and he's got a CocoRa's gauge there. And last year, 2020, they got about 60 inches of precipitation. 60. So I will be happy to get 9 inches where I am here in Las Cruces, but it varies across the country. And one of my first slides here is this is like the meteorologist's lava lamp. I really like these. Basically what this is water vapor. So if you were to put glasses on just to look at the infrared radiation coming off the earth and then looking at it over time, this is more than a day's worth of imagery looking at the Pacific Ocean. The reds are the really dry parts of the atmosphere, and then the blues, greens, those are our highest clouds. So they're like the cumulus, big, tall, towering cumulus, and the grays and kind of the blacks are kind of they're probably just the edges of the moisture, and you can see the kind of wispy nature. That this is weather. So as you can see, kind of pick your area where you live, and you can see where the lows pop in, the highs. Those are our clockwise moving, and then the counterclockwise moving lows. You can see there's some big features over in the Aleutians way over on the left side there, and then as they move across the Pacific, they change form and they spin around. So this is kind of, I just wanted to show you this kind of to give you an appreciation what goes on, what we look at from space, and the forecasters look at this, and you can see kind of one of the things I want you to notice is you can see over in the kind of the middle part, you can see over on the right, there's the winds are moving from the east toward the west. But if you look at it from over on the west coast, you can see winds are coming in from the west towards the east. And so those are our predominant wind directions that depend on where you are in the earth. And because we have a nice atmospheric system, we've got the earth rotating, creating these different patterns and bands of winds across the earth. And so I just want to give you that as a kind of appreciation of what goes on, above you and then over on the Pacific. So that's weather. And when we talk about climate, we look at areas where the air comes from on a long-term basis. And one of the things we look at as climatologists and as agroclimatologists is looking at source regions for the different air masses. And this is sort of a way to show where we get the air masses or across from different areas. So if you're in the northern tier state parts of the country and up in Canada, you get a lot more, you're closer to the Arctic air masses. You get these nice cold continental air masses that are dry. Whereas if you're more toward the southern tier states, you get more influence from the oceans. It's like where I am in the Southwest, we can dip into either the Gulf moisture or a bit in the maritime tropical. And so in different times of the year, we get seasonal effects from these kind of air masses. And I'll show you some examples of those when I talk about some case studies that we'll look at. So it all depends on the seasonality. And so also we look at, this is a surface weather map of the winter. So this is many years of data that we look at, and it basically shows us, let me turn on my little laser pointer, virtual pointer here. And so, and you can see in the wintertime, we've got these things called semi-permanent highs. Remember the air rotates in a clockwise fashion. And so during the wintertime parked over on the Pacific, we've got this high pressure system. So in the wintertime, and then we also have a low that's out over the Aleutians, and these can vary. They wiggle around depending on the large scale patterns of the atmosphere. And then in general, high pressure over the continental. So as these highs and lows move, they allow storms to go over into the continental parts of the U.S. And you also have the jet streams to kind of bring in high winds. And as you can see in the equator, you've got the trade winds are coming in from the east toward the west, and then in the mid latitudes where we are in the U.S., we've got winds that are coming in from the southwest to westerly flow. And then you can kind of pick anywhere in the world and kind of describe the general wind patterns and the types of weather in the wintertime. And then if we look at it in the later time of the year, in the summer, we see that semi-permanent high migrate up toward going higher up in the latitude. And then we've got a thermal low in the U.S. And so we get this high pressure basically reduces the amount of storms coming in across. And so we get dry part of the, especially on the West Coast, that's a dry time of year where it's wetter on the cool seasons. And we also have some other smaller effects like the monsoon popping up here. And then we also have this high pressure, this semi-permanent high pressure, they call it the Bermuda high. That's basically modulates where the paths of, remember clockwise, where the storms come in, bringing in moisture from the Atlantic, coming into the Gulf and bringing in nice moisture. So this is just giving you appreciation for the different climatological patterns of highs and lows, where the winds come from on a climate. And so we all care about precipitation. So this is the average, long-term average annual precipitation across the U.S. And this key on the bottom here goes from the really dark browns, less than 4 inches. And if you go all the way up into this really light violet, it's 160 inches. So I'm just kind of picking out, in areas in Montana, we've got, in the south central part of Montana, we've got areas that get around 6 to 7 inches on an annual basis. Whereas if you're on the northwest corner in the mountains, you can get upwards into like 35 inches. And if you go into Wyoming, you can see, a lot of variability in terms of elevational changes in the 5 to 8 inches in the lower Bighorn Basin. Whereas if you go into the mountains, you can get upwards of 40 inches. Then going into Colorado, the Rockies, you can get upwards of 60 inches of liquid precipitation in the mountains. And then you can see the area here, the dry area, the San Luis Valley gets, around 7 or so inches. And in migrating into down in New Mexico, all of our high precipitation is in our highest elevations. So we can get between 25 and 30 inches in some of our higher elevations. So we got weather stations up there to monitor it, especially all over the western US. And then in the far south, and also just on the leaves of some of the mountains, we get, on a good year, less than 10 inches of precipitation. And then in California, you can get probably one of our most diverse places, at least in terms of elevation as well as precipitation. In the southern part of the San Joaquin Valley down by Bakersfield, you can get 8 inches. And as you go further up into the Sacramento Valley, up to upwards of 18 inches. And then on the Sierra, on the west slopes, you can get upwards of 60 inches. So a lot of variability. And as you can see, as you get further, and as you move out of the Intermountain West, moving into the plains, Southern Great Plains, you can see this transition of all this area, it greatly influenced by the Gulf moisture. And so I'm going to give you a few locations in each state, kind of the water balance for one water year. So starting in October and then going to the end of September to next year. So October 19 through the end of September to 20. So this is on a daily basis. We've got a sensor called an atmometer that measures reference evapotranspiration. So basically it's showing you the over time, when there's not a lot of precipitation, we dip in the, we will dry out. And then as we go, we get precipitation, these blue lines. And then we go through the whole year. We've got a wet winter here, and this is Oroville, California. And so they had a pretty dry summer. So you can see it's drying out. And so we had almost 19 inches of precip, but we had almost 47 inches of evapotranspiration. Remember, the evapotranspiration, that's the sum of the plants transpiring, losing water vapor, as well as the area around the plant evaporating. So by the end of the year, the water year, we were in a negative amount of precipitation, 28 degrees net precip. And if you go into New Mexico, very similar. So we started off the water year dry, and then we had some precip. So we were in the positive part. We've had by the end of the year, we've had 10.34 inches of precip, but we've lost almost 38 inches from evapotranspiration, giving us a minus 28 inches of net loss. Going further up into Colorado, Fort Collins, much more precipitation throughout the winter going into spring, and then they dried out as they went into the fall. And so they had 17.6 inches total that water year, but then they had about 29 inches of evapotranspiration with a minus 11 net loss. And going up a little further up, all the way up to Montana, this is Columbus. I think this one is just west of Billings in the valley. So cool season precip did pretty well. And until the very end of the water year, about the end of September, it started to really dry out. So they had almost 14 inches of rain, but more than 17 inches of evapotranspiration with a minus 3.64 net. And then going finally into Sheridan, Wyoming, good precip throughout the cool season and even to the summer a bit, and drying out into the fall. So 11 inches of precip and minus 21 inches of evapotranspiration with a net by the end of the year of -10. So it just kind of gives you a sense of the aridity, or these vary on a year-to-year basis. And some years are more, there's a positive number, and some years we get a negative number. And this is kind of a good way to kind of see if there's any long-term trends, is to look at this on an annual basis, looking at, more than 10 years. And maybe Peter can talk about this, some of the sources for this information, but just kind of gives you some point information that kind of gives you the health of particular areas. And so what causes this weather variability? Some years we get a lot of precip, and some years we get drought. And it all depends on what time scale. So on a daily basis, we get things going on, weekly to monthly, seasonal, even on a year-to-year basis, and then all the way really long-term, decadal, so decades to several decades, and even longer in terms of changing climate. We have looking at a longer term. So these are the kind of the acronym soup over here, and the all these different names of different phenomena that climatologists have come up with to describe the fluid flow of the water vapor and the energy redistribution across the globe. And some of these are more important in different time scales, and then some of them are more important in different areas of the earth. And so we kind of use these things to describe what's going on, and they actually give us tools to forecast weather, not only on a day-to-day basis, but looking at even a seasonal basis, like right now. And I think Peter is going to talk about as we things called La Niñas and El Niños. What are the role of those, and what are they? And so we, some of the things that we look at, or that we care about, are some of the really extreme, the variability. And then I just picked this off from this past year. If you probably remember this, especially those in the Montana, and if you're in the Northeast Wyoming, you're in the midst of this. Actually, most all of us were in the West, except for those in California. We had an extreme cool season, cold air mass pop in. And this was in the beginning of February, first 2 weeks of February. And this is this little chart on the right here shows you the daily temperatures in Billings at the Weather Forecast Office in Montana. And you can see they started off, was really interesting. They started off with actually record temperatures in terms of highs. So this is showing you daily highs and lows. And so the high is here, the low is here. The next day, the high and low, high, low, etc. And then the red are the records for each day in terms of highs, and then the blues are the record lows for each day. And then the brown is the averages, high and lows. And as you can see, there's they dipped down from a record high on February 2nd, and then by the end of that week, they were into below zero for the highs, and then even going down into the -20 degree Fahrenheit. And that's pretty much the same story over most of the northern plains, all the way up to the Intermountain West, and at least the east sides of the mountains, and even parts of New Mexico dipped into that. Not as bad as the inner parts of the U.S., but those are some of the extremes we've seen. And the cause of those is we saw these Arctic air masses come in very dry and cold. And we can also get on the other extreme is on the wet side, where we tend to focus on drought, but sometimes in the middle of drought, we can get these, I wouldn't call drought busters, but they can deliver a kind of a wallop in terms of the amount of precip and water vapor. And this is one thing, especially for those who you're close to the coast in California. I mean, even in far into Oroville, in that area, into the northern Sacramento Valley, you can get these things called atmospheric rivers. This particular one occurred in February of 2017, and we've gotten all this water vapor coming in off of the Pacific, and very narrow amount of vapor. And then as it goes inland, it hits the terrain on the coast ranges and dumps a lot of precipitation. You can easily get more than 10, 20 inches of precipitation in some localized areas, but a lot of it can kind of get squeezed out before it goes too far inland. So you can even get these in as far south as into Southern California, but most time it goes into the northern northwest into the British Columbia, into the Northern California, or most frequently. And then for those of us down in the more southern parts, we can dip into these tropical storm remnants. And this is one that we had back in 2014. It was the tropical storm Norbert. And we had a pretty active year that year. And we actually, right after this one, we had a hurricane, Odile, who came in and visited us, and not the hurricane itself, but the remnants of all the moisture. And basically just see this kind of conveyor belt. You see this high kind of swirling off on the east side over Texas, kind of bringing in a clockwise motion, and then a low is going counterclockwise. Could you kind of see this kind of motion kind of drawing up the moisture through and kind of dumping it out on the higher elevations? And it all, it depends on the location of the high as they move. And this one, the later on in that month in September, the high moved out of the way. And so, it didn't get as high as Colorado, but then there was other opportunities. So this is kind of an example of kind of looking at the weather maps and seeing, we can get really dry years, but then all of a sudden you can get a big, big dip into these tropical systems kind of, and sometimes they're very narrow in terms of the amount of precip, but sometimes they can cover quite big areas. So this is another example of some of the impacts. This is a hailstorm, and so you can see basically decimates the crops. It really hurts you as you looking at these kind of pictures, but these are kind of the things we look for. So let's look at drought. What kind of drought, what types of drought we get from meteorological drought, short term, agricultural, longer term, hydrological drought, as it impacts our sources of surface water, as well as, dipping into, we have to rely more on the groundwater. And then over time, it impacts, as we, lose some of our resilience to drought, our incomes will be impacted. I know some of the folks in New Mexico now have to sell like 50% of their cattle inventory because of drought. And that basically impacts, the long-term, the genetics of their herd, as well as their income. And so that's kind of that social economic type of drought. And then later, over time, it can act and really impact our ecological environment. So those are different types of drought, and they all occur at different time scales. And so how do we gauge it? So one of the first things we do is looking at the impact. So we look at observations. So we rely not only just on the things we measure in the rain gauges, but looking at observable losses or changes, just like these pictures here. Just kind of, pick your favorite one, and just looking at, lack of water in some of our reservoirs, to animal fatalities, things like that. And here's another example. These are some of the ones that I've come across in my few years here in New Mexico. We've had things like snow drought. We basically see the lack of snow, in some of the higher elevations. When there's no snow in January at 10,000 feet, that's a case for concern. And looking at reservoirs that are normally full on good years all the way down, as well as impact on our rangelands, like over on the bottom right there, showing these stock tanks are completely dry. So we see the impacts, but then we also need to look at the observations of climate data. And so this is one of the things that we look at in terms of when we gauge drought, is look at things like the snowpack. If your area is dependent on surface water, as the snow melts in the spring, bringing down water to reservoirs and irrigation. I just picked one example here, and it's a station called the Snow Telemetry, and I just picked one in the Bridger National Forest over in Blind Bowl, and just to show you the type of graphs that you can get that shows the snow water equivalent. So how much water is actually in the snow on a particular time. And you can see over here, the current year, which has just ended, the snow season, is the blue line. And then the violet line is the average or median. And then last year was the green line. So we're below last year, and slightly below or pretty close to the long-term average. And just over on the right, showing but by looking at the percent median of different basins. And whereas like this year we're really struggling in some of our lower elevations in the lower tier states, but doing much better in the Pacific Northwest. And so we gauge drought, and we use Streamflow gauges to look at, in specifically the gauges that are over rivers that are unmanaged, because if we look at managed, it depends on how it's managed. But if we look at the relatively unmanaged streams, we can see the impacts compared to, and we put them in percentiles to see, comparing to past conditions. Some of them have more than 30, 40 years of data to compare. So looking at different, sorry about that. Sorry, there we go. And so my thing is going here. And so we also look at, I don't know why there we go. We look at surface water in some of our reservoirs. And I'm picked two in Colorado, the upper Colorado, as well as the upper Green River Basin going into Wyoming. And then looking at the Gunnison on the left, and then the San Juan on the right, just a sense of the impacts of drought over time, because a lot of times it's going to take more than 1 year to fill these reservoirs or to even to empty them out, and with the exception of some of the smaller ones. Going a little further down in latitude, going on down to the Pecos, Rio Grande, and the Rio Chama, you can see the impacts of the longer term drought. Our cups here are some of them are pretty empty, and especially over here in some of these bigger reservoirs that are normally 2 million acre feet, they're down to just below 200,000 acre feet right now. So this is sort of I'm giving you some of the tools that we look at in terms of the gauging drought. So where are we? We look at these a lot of these reservoirs would take more than one really good winter to fill them up. And then we have smaller surface water, like this one here is in the higher elevations, basically giving water to some of the wildlife as well as some of the range. And then I like to look at time lapse of the reservoirs. And this is kind of one just showing you the drawdown over some years, and then going into a bigger reservoir. This one's being drawn down over 1 year, over a summer, for irrigation. You can see the impacts of drought, from the large to the really low levels. And then we look at, this is the current maps on the left side is the average temperature, and then on the right is our precipitation. And and this is the last 12 months right now. And just to see the colors, where most of the West, further you go south, is much below, much above normal on the temperatures, and then much below average, and even record driest in some parts of the Southwest. Then we also look at soil moisture. This is we like to look at in terms of percentiles, and looking at this is a snapshot I just picked off a couple of days ago, looking at if we were down in the 0 to 10th percentiles, things are really looking dry, whereas we gotten some precipitation in some of the areas in Montana and eastern Colorado into Wyoming, but areas are to the west of that are still struggling in pretty intense drought. And then we look at the impacts to vegetation. So this is one of the satellite-based models that we look at to look at vegetation, where it's red is drought stress, green and blue are doing much better. As you can see, lots of parts of the West are still struggling with drought, as well as on North Dakota. We're seeing that impacts of short-term precip, and then also long-term. And then one of the final maps I'll show is the U.S. Drought Monitor. You're probably familiar with it, but if you aren't, this is a map that's generated every week, and it basically measures the extent and the intensity of drought, and it's on a 1 to 5 level. And you can see where drought is being impacting our southwest, and even you can see this area up in northeastern Montana and most of North Dakota is in drought. So these are some of the tools that we use, and the kind of over longer term, we like to look at, how does this year compare to, say, the last 50 years, or even some cases 100 years. So we can gauge aridity, which is more of the longer term, drying out, or in most cases, it's actually the signal is actually coming in. It actually is warmer. So our droughts are warmer than they used to be. Some of the 30s droughts or 50s droughts, they may be drier, but our droughts now are warmer. So that's kind of the pushing that aridity, getting drier, signal out there. So that's kind of our what climatologists, where we're looking at is tracking how above average is it, and then looking at things like evapotranspiration. So how does it manifest in affecting the vegetation out there? So I hope you get a sense of kind of what is drought by showing examples and seeing how this goes. And I think Peter's going to talk more about some more details on some of the tools that you have access to. So I'll end there, and then we could go to the next one.
Yeah, thanks for that, Dave. And we'll give Peter a moment to get his slides kind of pulled up. And I want to share with you a question that came into the chat as you were speaking, Dave. And Peter picked up the ball and offered a response in return. But let's give it a voice, because I know that at least one person is attending by phone tonight. So the question came in from Amelia: are the Arctic air masses typically more dry? And Peter responds, illustrating that there's a connection between moisture and temperature. Will you go a bit further on that, please?
Yeah, I mean, it depends on where the Arctic air mass came from. And so these cooler air masses typically will have less moisture. It's more of the thermodynamics of it. That's the technical part of it. But when you got more warmer air masses, they're characteristically have more water vapor. They don't always, but it's on average they do. And it depends on where the air mass came from. Did it come off of the coast, or is it more coming off of more of the Alberta going up further north? And those are more typically drier than the ones come up. They could be the same temperatures, but depends on the amount of water, they traveled, the trajectories.
Thanks for that, Dave, and to you also, Peter. So just a reminder, we'll wrap up with a Q&A/discussion session, and that'll take us no later than 7:30. But right now, it's time for our second presentation, and it'll be offered to you by Peter Goble. As I mentioned to you earlier, he's attending tonight from the Colorado Climate Center, or home base, it looks like tonight, more accurately. He's a service climatologist and drought specialist and coordinator for Colorado's COCO-RAS, the Community Collaborative Rain, Hail, and Snow Network. So take it away, Peter.
All righty. Is everybody seeing my screen that says Colorado Drought Update at the top? Perfect. All right. So as mentioned, my name is Peter. I'm with the Colorado Climate Center at Colorado State. Thanks everyone for hanging with me on this warm Wednesday evening. And thanks, Dave, for setting me up so nicely here. I am going to present a little bit outside of my PowerPoint first off, just on the fly, based on some of the things that I heard from you guys just at the beginning of this, hearing a little bit more about where you're from and what your backgrounds are. And my starting and ending point to my 20 minutes or so here is just to say that if you have questions and you're having trouble finding answers and they're weather related, contact your state climate office. State climate offices are a wonderful resource for any weather and climate related questions in your state. I'm going to show a couple examples of Western states' state climate office drought pages. But like I said, if you get in contact with the office, anything us weather nerds can do to make your much harder job a little bit easier, we love to do that. We're most of us, are tasked to do that by a state entity. We're usually located within the state's land grant university. In my case, that's Colorado State. But just as a quick example, here's our Colorado drought update page. Some of these graphics update weekly, some of them update automatically every day, but you can rifle through and see information on anything from precipitation, snowpack, temperature, soils, vegetation, so on and so forth. Just a couple of examples. Some of the things Dave talked about, we can look at vegetative health conditions based on satellite retrievals. We can look at soil moisture conditions. We have information about weather and climate outlooks, and that's what I'll spend the majority of my time on, is giving you some resources that you can tap into for planning for future horizons, anywhere from that afternoon to years in the future based on weather and climate outlooks. But like I was mentioning, a lot of the state climate offices have drought information and have a page like this. Now I'm on Montana's State Climate Office portal. The product that you're looking at here is called the Standardized Precipitation Index, or SPI, which is basically ranking how wet or dry precipitation is against the historical distribution. And you can pick different windows of time, like I just went from 90 to 365 days. But they've got all kinds of stuff from Mesonet data here, which I heard somebody mention in the saw somebody mention in the comments. State Mesonets are usually great weather and agriculturally related weather resources. Information on snowpack, precipitation, and all the different kinds of variables that control the different facets of drought that Dave talked about. Here's an example of the New Mexico Climate Center's page. Right now, I'm just on the home page. I'm sure if we rifled through this a little bit, we'd find some nifty stuff. You've got Dave's contact information at the bottom. We have a little widget here that's showing us drought information in the state. Of course, right now, New Mexico is in the thick of it. All right, that's my little unplanned intro. With that, I'll go ahead and open up my slideshow here. Let's see. All right, seeing my slides now? Perfect.
Yes.
Okay, so like I mentioned, I really want to look at some of the weather and climate prediction tools that are out there and how you might be able to leverage some of these just to help with your planning. And I'm going to do this starting with really short time scales, like this afternoon, for example, and go through to longer time scales, like over the next week to 2 weeks, month, season, and years from now. So we'll start with and I'll try to link most of these tools if there is a web page to go with it. You'll hopefully be able to find links to most of them on the slides, and I'm happy to share those. But the first tool that I want to talk about is RadarScope, and this is potentially the most important tool. There's certainly chance of severe thunderstorms in the summer anywhere within the Western US, particularly for regions that are affected by the North American monsoon. And if you have a good resource on your phone like RadarScope that can help you see where the storms are, if they're headed your way, and give you a little information about lightning, why not use it? A lot of seasoned farmers and ranchers have stories about, hiding in their tractors during a hailstorm. And if you can avoid that with a quick look at RadarScope, why not give it a try? I have this fun little anecdote at the bottom here. Men are 7 times more likely to get struck by lightning than women. Does that mean we're 7 times stupider? I don't know. I suspect that might be the case. But anyway, the weather tomorrow, when we talk about weather forecasting, this is what a lot of us are thinking about is, what's the weather going to look like tomorrow? And the spoiler alert here to me is that whether you're looking at, say, weather.com or your local news or AccuWeather, a lot of it comes from the same numerical weather prediction models. So basically, whatever choice of those you choose, I would say you can't really go wrong. Another little kind of inside scoop, I like weather.gov. It tends to be one of the most, if not the most accurate sources, and it has the least of a reputation for what we'd call crying wolf, or telling you it's going to be a big storm when it's not. And in fact, a lot of weather forecasting entities it purposefully build in a little bit of that to their forecast, because there tends to be more public backlash if you miss a storm rather than if you say a storm is going to be bad and it's not. I like my weather as accurate as possible. So weather.gov is a good place to get your forecasts for the next day or next 7 days. Of course, as Dave talked about a lot, you're going to care an awful lot about how much it rains and when. That drives a lot of the planning decisions in farming and ranching. You know, when do you get your tractor in the field? When do you harvest? Important things like that. One of the tools that we use a lot is this Weather Prediction Center quantitative precipitation forecast. Got a link there in the first little paragraph. This is an example map from this week. As we can see in the Southwest, it's a dry week. For some of you up in Montana, if you're in northern or western Montana, you might see a little bit more precip this week. But all of us out west, generally, you're going to see some dry weeks, a lot of dry weeks. I'll talk quite a bit about seasonal planning, and there's a lot to go through. Dave touched on, you know, determining what is normal. I'll add to that a little bit. Then we can talk about some of the levers that kind of control the makeup of a given season in weather and climate, whether that's El Nino, La Nina, or the behavior of the monsoon or other variations. A lot of this information is also available through cpc.ncep.noaa.gov. You're going to see a number of their products here over the next 10 or so minutes. Dave showed this exact map, but it's a great map, so I'll bring it back up. It's you know, a lot of these seasonal products, you're not going to get exact temperature and precipitation for each day of the year unless you're looking at, say, AccuWeather's 45-day forecast. But you know, once you get out past 10, 14 days, looking at that kind of individual daily data, they're feigning a lot of precision that they don't actually have. So when you look at seasonal forecasting products, usually it'll give you a probabilistic forecast, and it'll tell you something like if there's an increased tilt towards above or below normal temperature or precipitation. And of course, if you're going to use that information, you need a good understanding of what normal is. Here is that great map that Dave showed, giving average or normal precipitation for all locations across the US using the PRISM model. For most of you in the West US, in areas that you'd be doing farming and ranching, you're probably looking at an average of 8 to 16 inches of precipitation a year. You know, in these kinds of operations, that's sort of a shoestring moisture budget. You're probably in a desert-like or a steppe climate, meaning you're moisture limited at times, even in a normal year. Dave showed some of those examples of water balance throughout a season, and you'd probably noticed that most of them tank during the summer. That's when our evapotranspiration is high. And if you're in the West, odds are precipitation is not keeping pace. So as Dave mentioned, you know, you can have years with positive water balance, but if you're in the West US, particularly at low elevations, most years it's going to be negative. You can look at these normals on a monthly time scale as well. This is just an example I pulled for, I believe, somewhere in southeast New Mexico, and we're looking at monthly precipitation normals. You can see the influence of the monsoon, with September being the wettest month on average. But if you really want to get to know the normals in your area, I encourage you to use this tool from prism.oregonstate.edu, the Explorer. You just type in your coordinates and you'll get a lot of good information about not only your annual averages in terms of temperature and precipitation, but also kind of the seasonal breakdown of how things look. When should you expect to get most of your precipitation? All right, so some of the kind of mid-range forecasting or seasonal forecasting products that we look at come from the Climate Prediction Center, as I'd mentioned, and I threw up another link here, but you're looking at an example pulled from this Monday for the 8 to 14 day outlook for June 14th through 20th. Of course, now that's more like the 5 to 12 or 4 to 11 day outlook, but what it's showing is basically a probabilistic forecast of, do you have a tilt towards higher than average temperature or lower than average temperature expected on the left-hand graphic here. And then the right-hand graphic is showing, do you have a tilt towards expecting lower than normal precip or higher than normal precip? On the precip graphics, the deeper the shade of green, the bigger the tilt towards it's going to be a wet week. The bigger the deeper the shade of brown, the bigger tilt towards it's going to be a dry week. You'd probably guess from temperature too that the reds indicate hot, the blues indicate cold. As you can see from this 8 to 14 day outlook, heat waves very much expected to continue, unfortunately. Now, when I say these are probabilistic, one important distinction that I want to make, and I believe, it shows on this slide here, is just because you have a high tilt towards above or below normal doesn't mean you should expect it to be extreme that way or the other. For instance, with precipitation, if you have a high tilt towards above normal precipitation, that may just mean that there's really good confidence that you'll get, say, half an inch to an inch in the 8 to 14 day time frame. It doesn't mean that you should build an arc. They make these same forecasts for seasonal timescales. These are examples for June through August of this year. So again, we're looking at the reds meaning warmer than normal, the browns meaning below normal precip, greens meaning above normal precip. You'll notice that the areas in the white, on the last graphic, they were shaded in gray. So the white actually means something different than gray. The gray means that there's increased confidence that things will be near normal, whereas the white means that there's just equal chances of above and below normal. We affectionately refer to it as equally clueless. You'll notice also, looking at these seasonal forecasts, for this summer, we're expecting increased chances of above normal temperature throughout the Western US. And you're going to see this most summers in particular. I'll talk about this a little bit more in a few slides. Our climate is warming, and the season where that makes prediction the easiest is probably summer, because the day-to-day and week-to-week variations in temperature are just larger in the winter. The variations arise from differences in temperature from the poles to the equator. That ramps up the jet stream and makes for more violent action in the storm track that can either bring us way above or way below normal in the winter. Whereas in the summer, the difference in temperature between the equator and poles gets lower, and so the jet stream actually weakens and recedes to the north. So you have less week-to-week noise. So if you have this baseline change in your signal where the temperature is rising on a long time scale, you're probably going to expect that to have an influence, a big influence on your seasonal forecast. Okay, so this is a fun tool for farmers and ranchers called GrassCast. It's available at grasscast.unl.edu. And what this tool does is looks at, from the current date, if you project out normal precipitation or above normal precipitation or below normal precipitation. Actually, the tool, if you're online, gives you all three options. What should you expect your end of season grass production to look like? This is an example from last year, created on July 29th. This is the one assuming below normal precipitation through the remainder of the growing season, where we're seeing, big declines in the amount of grass production on the southern plains. It was definitely a drought year, but if we look at the above normal projection, things are a little bit better. So it gives you a sense of, in this case, eastern Colorado and eastern New Mexico, we were far enough into the season and the precipitation had already been low enough that we were pretty confident, even if you get above normal precipitation, the grass production's not coming back. If you looked at this tool for the current year in eastern Colorado, it's kind of the inverse, where we've had such a good May already that production is somewhat guaranteed to be decent. That's not true everywhere that this product is showing. If you're west of the Continental Divide, I apologize, this product is not showing your region yet. I think they're working on it, but because the grass type is different out that way, you need to use a little bit different calibration. All right, I like to throw this in when talking with farmers and ranchers. Beware the Farmer's Almanac. I still see the Farmer's Almanac get shared as a credible source in my local paper in Berthoud, Colorado from time to time, but it's not based on any real physical or numerical guidance. It'll often appear to be accurate because what they're basically doing is using these colloquialisms that describe the normal climate as their forecast, but it's not something that you can actually verify. For instance, if you're up in Montana, of course, winter you would probably expect to be frigid and snowy. And even if your temperatures for the winter were above normal and your snow is below normal, there's a good chance you could make the argument that winter was frigid and snowy. Not all of you are really in the path of the monsoon. A lot of you were Montana. There is some monsoon influence that far north, but not much. It's pretty marginal. The monsoon is a pattern that arises in the summer when we basically heat load the desert Southwest. When you have those long days and more direct sun angles, the land heats up much more quickly than the ocean. Hot air is less dense than cooler air, so you get this thermal low that sets up over the desert Southwest, and then typically a subtropical high further to the east. Now, typically, if you're to think of like a vacuum, air flows from high to low pressure. If you were to open the seal on a vacuum, air would flow straight in. Because of the rotation of the Earth, things get deflected to the right, and hence you get all kinds of nifty circulations like Dave showed at the very beginning of his talk. And in this case, in the case of the monsoon, it leads to corridors of moisture-rich air being ushered in to the desert Southwest in the late summer and early fall. The monsoon is a transient feature like any pressure pattern in the atmosphere. Don't expect it to be present all season. It's going to come and go. But this website listed at the bottom is a great feature for tracking the monsoon. All right, I want to talk a little bit about El Nino. If I keep using this Chris Farley image with young farmers and ranchers, it may start to date me eventually, but I really like his El Nino sketch. El Nino versus La Nina refers to a temperature pattern in the equatorial Pacific that has impacts on atmospheric circulation, worldwide, but some of the important ones that come into play for the Western US are during El Nino, you might expect warmer or drier, say up in Montana, particularly during the winter and spring, and cooler, wetter than normal down in the Southwest. And we basically see the inverse of that during La Nina. If you're lucky like me and you're in the middle of the two, you basically get no predictive skill out of it. But if you're down in New Mexico or up in Montana, you will be able to kind of get some predictive skill out of ENSO. Here's an example of the ENSO forecast going forward, where we're actually looking at probabilities of La Nina in the blue, El Nino in the red, or a neutral year for different times of year going through December, January, February of the coming year. As you can see, La Nina is preferred to strike again this year. It was there last year, recently fizzled out. Good chance it comes back. Now, I just want to do a couple slides on climate change and what's going on long term across the Western US and the globe. We get a lot of questions as climatologists about, we get the weather wrong all the time for the next week or even tomorrow. Why should we trust that things are warming for 50 years from now? And the answer to that question in particular is nobody sane is trying to give you a forecast for a specific day 50 years from now. There will still be plenty of wacky day-to-day and even year-to-year variations, but we know that the baseline is moving because we're changing the chemistry of the atmosphere to include more heat trapping gases. So as the Earth tries to radiate its energy out to space, energy that would have otherwise gone straight out to space is absorbed and re-emitted at the surface. So in order to maintain an equilibrium, the surface has to get warmer. If you want to think of a simple analogy for that, weather is what you wear today, climate is your entire wardrobe. Another analogy that I kind of like that one of my colleagues came up with is it's kind of like if somebody was going to eat nothing but fast food for the next 50 years, it's probably a fairly safe assumption that they are going to gain a little bit of weight. You know, we might not be able to predict exactly which days they have indigestion 50 years from now, but we'll probably be able to conclude that their waistline will be different. What I have, the slide that I have here is showing for the southwest region of the US, the average summer temperature going back to 1895. Last summer was the warmest on record for the Southwest so far. And you can see that we're getting a lot more of these dots on the high side of the long-term average, and we're losing the dots on the low side of the long-term average. So I'd say it's important in planning to know that things are likely going to continue to get warmer. And as Dave had touched on, that has implications for things like aridity, because your crops are going to use their moisture more quickly under warm conditions. If you're ranching, some of the ways that you can mitigate that are to, you know, keep the cattle moving, make sure you're not grazing to the crown, maybe be a little bit more conservative with herd size at the beginning of the season. You know, if you're farming, it may influence what you ultimately decide to grow. It may influence what kind of water rights you look for. All right, I think I'm a little bit over on time, unfortunately, so I'm going to kind of rifle through these pretty quickly. Dave talked about the US Drought Monitor already. It's a kind of a one-stop shop for drought information. It gives you an overall appraisal of what drought conditions look like, and it's you know, really designed to follow a percentile ranking classification. So the most extreme category or exceptional drought is reflective of the bottom 2 percentile of all years, or like a 1 in 50 sort of event. The D3 is bottom 5%, D2 is bottom 10%, and so on and so forth. If you're a rancher, this may end up being important, an important tool to look at to figure out if you're getting federal relief through the livestock forage program, and as I believe that those are connected. And then just ending with my same point that I started with, that your state climatologists are your friends. I included a couple of links to state climate office pages. I was focused more on the Southwest. I certainly wish I had included Montana after hearing the things at the beginning of the presentation. Montana has a fantastic state climate office. I guess we will end there.